Here we're going to find the exact value of a trigonometric expression. We want to find the exact value of the cosine of sine inverse of 2/3 plus tangent inverse of 3/2. We're going to start off by defining two angles. We'll let alpha equal sine inverse of 2/3. If we sine inverse of 2/3, that means that the sine of alpha is equal to 2/3, and alpha needs to be in quadrant 1. We'll let beta equal tangent inverse of 3/2, which means that the tangent of beta is equal to 3/2. Again, beta needs to be in quadrant 1. Since we know that the sine in a circle will be y over r, we consider a circle of the form x squared plus y squared equals r squared. Here you have the sine of alpha is equal to 2/3. So we have y is 2 and r is 3. If we put those into our equation, we'll get that x squared plus 2 squared equals 3 squared. Which gives us that x squared is equal to 5. We know that we're in quadrant 1, so x needs to be positive. So we'll get that x is equal to the square root of 5. We'd like to find the cosine of alpha, so we'll need that later. The cosine of alpha is equal to x over r. In this case, we have that x is the square root of 5, and the radius r is 3. So cosine of alpha is equal to the square root of 5 over 3. We're going to work on this beta now. We know that the tangent of beta, tangent is equal to y over x. In this case, we have 3/2. Again, consider a circle of the form x squared plus y squared equals r squared. In this particular case, we know y is 3 and x is 2. So we'll have 2 squared plus 3 squared equals r squared. So we'll solve this for r and get that r is equal to the square root of 13. Now that we've found the tangent of beta, we also need to find the sine of beta and the cosine of beta so that we can finish our problem. Here we've rewritten the expression that we'd like to evaluate. We've also got the sine of alpha is equal to 2/3, cosine of alpha is equal to the square root of 5 over 3, and tangent of beta is equal to 3/2. We'd like to find the sine of beta. The sine of beta is going to equal y over r, and we're using the angle beta here. Y was equal to 3, and we found on the previous page that r was the square root of 13. So we'll have the sine of beta is equal to 3 times the square root of 13 divided by 13. We'll also need the cosine of beta. Cosine of beta is equal to x over r. X is 2. And we had r was the square root of 13. So cosine of beta is equal to 2 times the square root of 13 divided by 13. Now remember that we defined the sine inverse of 2/3 to be alpha, tangent inverse of 3/2 was beta. So what we're really looking for is the cosine of alpha plus beta. We're going to use the sum rule for cosine to rewrite this as cosine alpha cosine beta minus sine alpha sine beta. Then we're going to plug in our known quantities. You know that cosine alpha is the square root of 5 divided by 3. Cosine of beta is 2 times the square root of 13 over 13. Sine of alpha was 2/3. And the sine of beta is 3 times the square root of 13 over 13. If we clean this up and simplify, we'll get 2 times the square root of 13 times the square root of 5 minus 3, all divided by 39. So the cosine of sine inverse of 2/3 plus tangent inverse of 3/2 is equal to 2 times the square root of 13 times the square root of 5 minus 3, all divided by 39.